Have you ever wished you could step into a time machine and travel back millions of years to see dinosaurs roaming the earth, or witness the rise and fall of ancient civilizations with your own eyes? Imagine standing where pharaohs once walked, or watching a T-Rex thunder across a prehistoric landscape. It sounds like something out of a science fiction movie, right? Well, here's some amazing news. Thanks to science, we actually have a way to journey into the past. Science gives us the power to unlock secrets that have been buried for thousands, even millions of years. Think of science as our real-life time machine. It lets us uncover incredible stories hidden in rocks, ice, ancient seeds, and even the tiniest grains of sand. Every discovery is like opening a window into a world long gone. Every object from the past, whether it's a fossil, a tool, or a piece of pottery, has its own unique story to tell. Science gives us the tools to listen to those stories and reveal the mysteries they hold. One of the most fascinating tools scientists use is called radiocarbon dating. It's almost like asking ancient objects, "How old are you? When did you last live or grow?" This technique helps us put a date on things that lived thousands of years ago. It might sound like magic, but it's actually a scientific process. Radiocarbon dating uses a special kind of atom, carbon-14, as a natural ticking clock inside every living thing. When a plant or animal dies, its atomic clock starts ticking down. By measuring how much carbon-14 is left, scientists can figure out exactly how long ago it lived. This lets us piece together the incredible story of our planet, one discovery at a time. With radiocarbon dating, scientists become real-life time travelers, solving mysteries from the past and connecting us to the people, animals, and events that shaped our world. Are you ready to discover how a tiny particle can reveal the true age of ancient monuments, fossils, and artifacts? The answers might surprise you. Let's dive deeper into the fascinating science of time itself, and see how we can use it to unlock the secrets of our past. So what is radiocarbon dating? It might sound like something out of a science fiction movie, but it's actually a real and powerful tool that scientists use every day to unlock the secrets of our past. Radiocarbon dating is a method that allows scientists to figure out the age of things that were once alive, like wood from an old shipwreck, bones from an ancient burial, or even tiny seeds found in a forgotten cave. If it was once part of a living organism, radiocarbon dating can help reveal its age. But what about rocks or metals? Unfortunately, radiocarbon dating doesn't work on those. Rocks and metals never breathed, grew, or absorbed carbon, so they're left out of this particular scientific story. But for anything that was once living, radiocarbon dating can open a window into its history, telling us when it lived and sometimes even how it died. Imagine you're an archaeologist and you discover an ancient wooden spear buried deep underground. You might wonder, how old is this artifact? Who used it and when? Is it just a few hundred years old, or could it be thousands of years old, dating back to a time before written history? This is where radiocarbon dating comes in. By analyzing the spear, scientists can determine its age with surprising accuracy. The secret lies in a special type of carbon called carbon-14. All living things absorb carbon-14 from the atmosphere while they're alive. Plants take in carbon-14 as they grow, and animals get it by eating plants or other animals. But when a living thing dies, it stops absorbing carbon-14, and the amount inside it starts to decrease at a steady, predictable rate, like a natural clock ticking down. By measuring how much carbon-14 is left in an ancient object and comparing it to the amount found in living things today, scientists can calculate how long it's been since that object was alive. The radio in radiocarbon refers to the fact that carbon-14 is radioactive. It slowly breaks down over time, and that's the key to this scientific time travel trick. In short, radiocarbon dating measures the leftover carbon-14 in ancient objects, allowing scientists to wind back the clock and discover their true age. It's a brilliant blend of physics, chemistry, and detective work, helping us solve some of history's greatest mysteries and piece together the story of our world. Thanks to radiocarbon dating, ancient artifacts become storytellers, sharing their secrets and connecting us to the people and events of long ago. Let's meet our star, carbon-14. Cosmic rays from space hit our atmosphere, turning nitrogen into carbon-14. This carbon-14 mixes with oxygen to form radioactive CO2, which plants absorb during photosynthesis. Animals eat the plants and the carbon-14 moves up the food chain right into us. As long as something is alive, it keeps absorbing carbon-14, staying in balance with the atmosphere. The ratio of carbon-14 in living things matches the air around them. This balance is the starting point for our atomic clock. Once an organism dies, it stops absorbing carbon-14, and the clock starts ticking down. Scientists know the starting level so they can measure how much is left to determine how long it's been since death. That's the secret behind radiocarbon dating's power. The countdown begins the moment life ends. When a living thing dies, whether it's a plant, animal, or even a person, it stops absorbing carbon-14 from the atmosphere. This special form of carbon is constantly taken in while alive, but the moment life ends, the intake stops completely. From that point on, the carbon-14 inside the remains begins to decay. Over time, these unstable atoms break down, transforming back into nitrogen atoms, a process that happens invisibly but steadily. This decay doesn't happen all at once. Instead, it follows a precise and predictable rate known as the half-life. For carbon-14, this half-life is about 5,730 years, meaning it takes that long for half of the original carbon-14 to disappear. After one half-life, only half of the original carbon-14 remains in the sample. This is a key marker scientists use to measure time. After 2 half-lives, just a quarter is left. With each passing half-life, the amount of carbon-14 keeps halving, creating a clear timeline of decay. This steady mathematical decay acts like a built-in stopwatch, ticking away inside every once-living thing. In the lab, scientists use advanced machines to measure exactly how much carbon-14 is left in a sample. They compare this to the amount of stable carbon, giving them a ratio that reveals the sample's age. For example, if only 25% of the original carbon-14 remains, scientists know that 2 half-lives have passed, about 11,460 years since the organism died. Using this method, researchers can accurately date ancient objects like bones, wood, or charcoal up to around 50,000 years old, unlocking secrets from the distant past. Beyond that age, the remaining carbon-14 is so tiny it's almost impossible to detect, making it hard to measure anything older with this technique. Still, this powerful calculation has helped us uncover the ages of ancient campfires, prehistoric bones, and countless artifacts, piecing together the story of life on Earth. The half-life equation is the secret behind radiocarbon dating's remarkable accuracy, allowing us to trust the dates we find. It's like a universal clock, quietly ticking away inside every cell of every living thing, marking the passage of time even after death. By reading these atomic clocks, scientists can literally read the ages written in atoms, revealing the hidden history of our world. Thanks to science, not guesswork, we can reconstruct the timeline of life, one atom at a time. Radiocarbon dating revolutionized archaeology, turning guesswork into science. Take the Shroud of Turin, debated for centuries. Radiocarbon dating showed it was made in the Middle Ages, not ancient times. In Egypt, dating organic materials from tombs helped build a reliable timeline for pharaohs and monuments like the pyramids. Stonehenge? While the stones can't be dated, tools and remains left behind can. Radiocarbon dating revealed it was built in phases over 1,500 years. This technique gives us construction schedules for ancient wonders and solves mysteries that puzzled generations. It's the scientific flashlight that lights up the dark corners of history. With radiocarbon dating, we can finally put dates to humanity's greatest achievements. The past becomes clearer, one discovery at a time. That's the real magic of this atomic clock. Radiocarbon dating isn't just for ancient history, it's a modern detective tool too. Forensic scientists use it to help identify unknown human remains and determine time of death. Thanks to nuclear testing in the 1950s and 60s, there's a bomb pulse of extra carbon-14 in the atmosphere, recorded in our bodies. By measuring carbon-14 in tooth enamel, scientists can pinpoint a person's year of birth within a year or two. This has helped solve cold cases and bring closure to families decades later. Radiocarbon dating bridges the gap between past and present, turning atomic clocks into tools for justice. It's science in service of truth. Even today, this ancient clock helps solve modern mysteries. Radiocarbon dating helps us read Earth's climate diary, not just human history. Scientists use it to date tree rings, revealing past droughts and good years, and to anchor timelines in ancient logs. Ice cores from glaciers trap bubbles of ancient air. Radiocarbon dating tells us exactly when each layer formed. By combining tree rings, ice cores, and ocean sediments, scientists build a detailed climate history. Radiocarbon dating syncs these records, showing how volcanic eruptions or droughts affected the planet. This data is crucial for understanding today's climate changes. The atomic clock doesn't just tell us about people, it reveals the story of our planet. It's the key to Earth's environmental past and future. Radiocarbon dating is powerful, but it has limits. It only works on things up to about 50,000 years old, too recent for dinosaurs. The sample must be organic. Wood, bone, cloth, or charcoal. Stone, pottery, and metal can't be dated directly. Archaeologists get creative dating organic material found with artifacts, like burnt food in a pot. Contamination is a challenge. Even a touch can add modern carbon and skew results. Scientists use gloves, sterilized tools, and chemical cleaning to protect samples. The amount of carbon-14 in the atmosphere has varied, so scientists use calibration curves from tree rings and other sources to correct dates. These extra steps make radiocarbon dating even more precise. Knowing the limits is as important as knowing the science. Even the best time machines have boundaries. We've traveled from atoms to ancient tombs, from climate records to crime scenes, all thanks to carbon-14. Radiocarbon dating gives us context, not just dates, anchoring the story of humanity and our planet. In archaeology, it's replaced myths with scientific timelines, revealing how civilizations rose and fell. In forensics, it gives a voice to the voiceless, helping solve crimes and bring closure. In climate science, it's the foundation for understanding how Earth's environment has changed, and why today's changes are so dramatic. By knowing our past, we're better prepared for the future. Radiocarbon dating is a testament to human curiosity and ingenuity. It shows how understanding the tiniest particles can unlock the grandest stories. Our time machine is built from knowledge, not gears. Keep exploring. Science is the greatest adventure of all.